Welcome to Los Angeles Data Platform User Group. This session is going to be recorded and shared on our YouTube and Rumble channels. Good time of day, everyone, wherever you are. By the way, please feel free to drop your city and country into the chat so we know which communities we're serving. Welcome to Los Angeles Data Platform User Group again. Thank you for joining us today. My name is Sif, and I'll be hosting this virtual meeting.
Terms we were in. I'm Chris Hyde. My pronouns are he, him, and I was just recently lucky enough to be renewed as a Microsoft Data Platform MVP. In my day job, I'm a BI and DBA consultant, and I'm in Albuquerque, New Mexico. The most important bit on this slide is the bottom right. If you like the session and you're a Twitter user, please go tell everybody publicly how much you liked it. You know, if you don't, if you think there's something that I could do better next time, that's what the email's for. It's a good way to let me know without the kerfluffle of Twitter. But seriously, if you have any questions, I'll be glad to take them later in either medium. If you're anything like me, you'll have a great question 5 minutes after the session's ended. Just contact me either way. So we're going to talk about Microsoft Fabric today, but it's going to be a real 100 level overview, right? This was just announced at the end of May at Microsoft Build. We're 6, 7, 8 weeks in, maybe. So we're still in public preview here. We're adding more features all the time. And this is definitely not a deep dive. So if you all are on here and you've gone through all the Microsoft Learn tutorials and you've watched all the Guy in a Cube videos about Fabric, you're not going to learn too much this evening. I just want to be honest with you up front. This is more a session for those of you who haven't had to encounter Fabric yet. It's a very high level introduction. Right. We're going to talk about their OneLake, which is their sort of the data lake equivalent that is underpinning all of Microsoft Fabric. And we'll talk about lakehouse architecture, which is sort of the data analytics paradigm that Fabric is following. And we'll discuss a lot of the different components. But as we'll see, there are many, there's quite a lot going on in Fabric, so we won't have time to demo all of them today. So I'll just demo a couple and maybe hopefully get you all interested, and then maybe one of you all will like to write your own session on one of the bits that I didn't get to yet. All right, so what is Fabric? So it's Microsoft's next generation. It's their all-in-one analytics product. It's got data warehousing, it's got data engineering, it's got data science tools, but it's built into the same portal as Power BI, so it's still got all the Power BI features that you know and love. And the experience is very like the Power BI experience. So it's a software as a service kind of deal, where you get Fabric and it's one place, one portal. You're not going into the Azure portal, you're going into the Power BI portal to do everything here. And so because it's software as a service, you'll think about what our analytics stack might look like, say in AWS, right? So we've got, I don't know, Apache Airflow to move data in. We're putting that in our lake, which is on an S3 bucket. And we're doing transformations. Maybe we're using Informatica. Maybe we're landing the data in Redshift or Snowflake. And maybe we're using Tableau or ClickView or something. I mean, that's a lot, right? And you have to make sure all those different components can talk to each other. And that's difficult, especially for our citizen developers, those of us who are sort of IT pros, that level of business analytics practitioner. Okay, we might have some experience with the networking and credentialing and security that we need to get those set up. But most of our users don't. Right? Even in the, I picked on AWS there, but in the Microsoft cloud, it's been very much the same kind of situation. Right? We've got our data lake. We're using Data Factory to put data in. We might be using Databricks for a transformation, et cetera, et cetera. Now we're putting all of these into one package, all these different capabilities, not necessarily the individual tools. We're putting them all into one package, and all the linkages between the different experiences, the warehousing, the data engineering, the data science, the visualization, that's all set up for us. So it's about as turnkey as you can get for an analytics product. The other important cornerstone is that we're only going to have one copy of our data. Once we land it in the One Lake, that's their name for the data lake that underpins everything here, we're not going to need to move the data to somewhere else. We don't need to have a separate Power BI data set that refreshes, for example. We've got one copy of the data, no need to spend a lot of time moving it around. So that's the high level view here. Like I said, this is in public preview. So you all can play with it now, but by the time this goes to general release or general availability, which presumably is later this year, some things may have changed. Names may have changed. Screens may look different. So just keep that in mind, that what we're looking at today is still a relatively early release. And in fact, I'll show you a couple places where things aren't working great for me. And that's okay. I'm not too worried because we're in this preview mode. This isn't something that I'm going to tell you all to move all your data analytics workloads to tomorrow. But the point of the presentation is that you need to keep an eye on this and where this is going, because in my mind, this is the biggest change in the Microsoft Analytics stack since they introduced Power BI. I think all the different teams, the Synapse team, the Power BI team, the Azure ML team that are all working on this, they're all rowing in the same direction. They're going the same place, and Fabric is the Microsoft solution going forward. So while it's not, ready for full enterprise production today, this is the direction that they're going in. So I hope that, I've kind of set the stage for kind of why I think it's important to talk about. So as we go through this, I've included some slides that are made by one of the Microsoft employees over in France called Christophe Manier. He's obviously a much better graphic designer than I am, and there's lots of information packed into these slides. So I'm not going to go into the details of any of those, but if you'd like to download the deck or later, these are all there for you to go through, maybe pick up a few more pointers. For example, I mentioned software as a service, or SaaS. If that's a term that you're not deeply familiar with, you can come to this slide and learn a bit more, and there'll be some links as to where you can go to find out some more info. So this is sort of the logical foundation of the software as a service Fabric platform. We see that we've got this One Lake thing in the center, and I'll talk more about that. But we've got all our components, our data factory component, our Synapse data engineering. So this is our Spark pools. Our Synapse data warehousing. This is our Synapse serverless pools. There's no dedicated pools going on in here. And then we've got our data science piece. That's like our Azure ML Studio, those kind of things. We've got our real-time analytics for looking at streaming data or other time series type of data. And that'll be using Custo or KQL to query that data. And of course, probably most of you are already familiar with Power BI. So let's talk about that One Lake piece in the center. This is the Microsoft marketing speak, is the first line. They want it to be the OneDrive for data. They want it to be as simple to put data into their data lake, your data lake, right? They want it to be as simple to put data into your data lake as it is for people to use OneDrive to put files in. So it's got the full compatibility with the existing Azure Data Lake Storage Gen 2. And it's got a shortcut feature that allows data virtualization across, other Azure Data Lakes, Amazon S3 buckets, and soon they say it's going to be able to connect to Google Storage as well. So you can have a shortcut in the lake that just points out, and for all intents and purposes, logically, it's like the data is already in your OneLake. And the data is stored in an open source format. When you're storing flat files, of course, they'll be just in whatever file format they come in. But when you move them into data tables, these delta tables are the open source parquet format with the delta layer on top. And I'll talk more about what that means as we go on. So again, Christoph has a nice view of OneLake. I'll leave it just for a second. So here is kind of a slightly deeper look at that foundation. We see we have OneLake in the same place, but we see it's got some objects in it. We see it's got a data warehouse, a data lakehouse, a CustoDB for real time, and our Power BI data sets. But note beneath that, all those say that they're Delta Parquet format. So, we've got the same open standard storage mechanism across all our different, I won't even call them engines, really, but all our storage is, the same structure across all of our lake. And then we have serverless compute power that we provision across our different experiences. So our Spark pools, our T-SQL stored procedures, perhaps for our data warehousing, KQL for the real time, or analysis services for Power BI. So a little bit about this parquet format, and I know this slide is very busy. So I like to make the analogy between, inside your SQL Server, you've got a lot of your tables are just standard, row store. You're storing row by row by row. But you have the option to do a clustered column store, which stores things very differently, is very good for large quantities of analytical data. That's great for compression. So that analogy, that difference between row store and column store is like the difference between a CSV and a parquet file. So a parquet is like a column store equivalent of a flat file. But it's an open format, so it's being used by a lot of other technologies, a lot of other places in the cloud. So it's great to have one method to standardize on. So a lot of this is taking its cue from something called the data lakehouse. And I know a number of you on the call are familiar with this term, but I want to make sure everyone is familiar. So this is something that was coined by Databricks. And you see the quote there, it's an open architecture that combines the best elements of data lakes and data warehouses. And you see, this is fairly new from a couple of white papers just from the last 3 or 4 years. And a lakehouse has 10 key features, and it's often organized in Medallion architecture. So that's what we'll look at on the next few slides. So here are the key features of a lakehouse. And so, like, if you have a regular data lake, you don't have any transaction support. You don't have that ACID compatibility that you would think of in a database. But so in a lakehouse, we need to have that ACID compatibility on top of the items in our data lake. We also need the level of schema enforcement and governance. And it's the Delta layer on top of the parquet that's providing that. It also needs to support BI tools. So one way that is great to support the BI, have all the data in that open standard, that parquet standard that many business tools can read. It's not enough to just put everything in VertiPack and then only Power BI can read that. We're opening things up here. And it's important for storage to be decoupled from the compute. So you think of your SQL Server system, your SQL Server files and your SQL Server engine are very tightly coupled. You can't separate those. But here, our storage is in our data lake. It's completely decoupled from our compute that we pay for separately, we provision separately, and it's serverless, so it's only running when we need it to be. I've mentioned open standards a couple of times. And we want it to support both structured and unstructured data. Well, data lakes have been great at that for a while, but data warehouses are not necessarily great at managing unstructured data. So this is where we're combining, again, the best parts of both worlds, data lakes and data warehouses into a lakehouse. And we want to support multiple types of analytics workloads. It's not just the standard star schema. We also want to be able to look at streaming data, all from one system. And of course, we've got to have the level of security and access control to be able to secure our data. And ideally, we want some level of a data governance tool, a data cataloging tool in place as well. So those are the 10 key features that make something a lakehouse. And Delta Parquet is what allows us to do this, because the Delta layer provides the compatibility for the ACID transactions, and it helps us to manage schema drift as the structure of our data changes. But so this is a layer that is sort of on top of Parquet. You can't have Delta without it being Parquet underneath. So all Delta is Parquet, but not all Parquet is Delta. A lot of people don't even like the term Delta Parquet that Microsoft really likes at the moment because they think it's redundant. So some people will say Parquet in the Delta format or just Delta. So you'll hear kind of all three of those, probably some other other permutation that I'm forgetting, but Delta Parquet, Delta, it's the same thing. And I mentioned that we structure things in our Medallion architecture. So if you've been working on data lakes for a while, you might be used to sort of a raw area, a curated area. The lakehouse architecture goes in bronze, silver, and gold layers. And they're similar to what you've used before. The bronze layer is our raw data. Maybe we're making staging tables out of it, just kind of putting the data into a tabular format, but not changing any of the topology. That's bronze. Then in the silver layer, we're starting to cleanse it, conform it, deal with missing data a little. We might be restructuring it into third normal form, putting the relationships between the tables in the silver layer together. And then the gold layer is sort of a final analytical layer. It's fully curated, fully transformed. It's most likely in a star schema, so modeled into facts and dimensions. And there's a link to an article here where you can learn a little more about that. So, Steve, any questions so far?
No. And for attendees, if you want to ask a question, just raise your hand and I'll just unmute you.
All right, so let's hop over into the demo and let's take a look at the lakehouse. Here we are. So I'm going to start. See, this is just a regular kind of Power BI area. In fact, I can go from here straight to Power BI. Looks just the same. So I'm going to start off, and I'm going to my workspace. This is So the logical area that is going to hold my lakehouse, my data warehouse, my machine learning artifacts in one space here. And you see it's blank, there's nothing. So I'm going to go ahead and create a new lakehouse. Okay, this takes a few seconds to come up here. And so it's empty right now. Let's bring a file in. And so this is a fairly small file. We can take a quick preview and see this is just standard, flat file sales data coming in. Well, one thing that we might want to do with this is make a table out of it. So this takes our flat file and creates our Delta Parquet table. But I didn't have to write Python code to do that. I just right-clicked and sent it off to create. So this is something that any of my Power BI users can do to bring data in, right? They don't need to be data engineers in order to get data into a Delta table. So here's my table. Let's see a quick preview. And there, as we can see, it looks like our tabular format. Note we've got this unique identifier on the left, just like if we were creating a data frame in Pandas or PySpark, we would be creating this abstract number to identify each of the rows. If we didn't, identify a primary key up front, yeah, same thing that we've done here. Now we can view the files, and here's our parquet. And here is our delta log, and we can see that we're logging what we've done here. Here's our operation. We've created the table, and it's a select from the file. And if I scroll across some here, I should see, okay, this is how many records we've inserted. Here's our minimum value. Here's where we started. Here's where we stopped. So we're starting to be able to track our transactions like a transaction log does. So let me hop back here a second. Let me go back to the workspace. Because what I wanted to point out, I've created my lakehouse, but I've got two other objects by default. I've got a SQL endpoint with the same name, and I've got a Power BI dataset with the same name. So I can click on this SQL endpoint and give me a second, I can write a so I'm not sure what I clicked there. I think my hand brushed the touchpad here. Lost my top 10 on the way there, but yeah, you get the idea. So yeah, our users don't necessarily need to be we're in a lake house, we've moved everything in. Our users don't need to know Spark to create our data tables or to do simple analysis on the data. We've even got the ability to visualize the results, and it'll connect this to a data set to build a nice little report here, and we can start dragging and dropping some of these things. and we end up with, well, yeah, not so good so far, but we can actually build a Power BI report right off this text file that I've just dropped into the lake without having to do any data engineering to it. Yeah, I can also, if I go here, I can do a drag and drop style query if a lot of my users are not experienced with SQL, but they've been using Power BI for a while. They might know how to do visual queries pretty well. So we have that that option as well for them. All right, so I think that's everything I wanted to show in here for right now. So let me discard those changes. Back to here, and let's continue on with the slide. But there's more here. There's a link here if you'd like to go learn more about the lakehouse piece. Let's talk then about the data warehousing piece. So this is a more traditional warehousing experience where we're dealing with structured data, usually in a star schema relationship, facts and dimensions. And we're developing primarily with T-SQL. So we can build stored procedures in here. We can build views and functions. And we can use that visual editor as well. But even though we're using SQL, our data behind the scenes is still stored in that same open source Delta format. So let's hop back over and look at what that's like. So let me go ahead and create a warehouse. All right, so I'm going to go ahead and create some tables with T-SQL. So let's see, we've got a couple of simple ones here. I'm going to go ahead and create a product dimension. And it probably would help if I created the schema first. There, that's going to be more successful. And let's just drop a few products in here. Okay, so this is taking a few seconds, right? Because behind the scenes, we're spinning up our, serverless pool, running the job and then shutting our pool down. So it's not like we have, a SQL engine running all the time. So things are going to take a little bit longer than you might be used to because of that. So, don't be alarmed that it takes 6 seconds to load 3 rows. Right. And so we've got the same experience of previewing our data graphically, querying visually, or going back and writing select statements against that table. So let's look at a little more data. And again, I need to remember to create my other schema. Okay, now we're okay to run. And we see we've got our dimension tables, we've got our fact tables, and then I can go ahead and just write the kind of standard query that we might think of when we're looking at sales data. So we've got our fact joining in a couple of our dimensions and then grouping by some of the data. And we get our nice summary very quickly. So we also, if we click on model, at least if this was working correctly, which is one of the things that's not quite working right now the way it should be. So I'll show you what it should look like. Yeah, it should look like this kind of thing, where we have our 4 tables, and then we're able to create relationships between them to create an ERD. And then just like in the lakehouse experience, let me go back to my workspace here. Yeah, we have created our data set that we can read straight ahead in Power BI and write reports against it. And so I won't go any further into that. I assume
Chris?
most of you have seen Power BI by now. Yes, Steve.
Chris, there is a question from Tim. Tim, let me
Okay.
unmute you.
Okay, go ahead.
Tim, I think you unmuted now. It's complicated. Okay, I don't know how to do it. Looks like
sorry,
he's
Tim,
unmuted.
we can't hear you.
I guess continue.
Okay. Tim, if you have access to the chat, maybe you can type in there. It looks like Uday has a question as well.
Hello, can you hear me?
Yep.
Yeah, Uday, is that you?
Yes, yes, Chris. Yeah, could you cover something about the licensing as well?
Yes, I will. That's on one. It's not to make you stay to the end, but that is just about the last slide.
Okay, thank you. Thank you.
So yeah, it's not a dirty trick, but I promise I will talk about it.
Sure. Yeah, thank you.
Okay, Tim, do you want to give it one more try before we switch back to the slide deck? Oh, that's better.
Okay, thanks. Yeah, thanks. So let's suppose that we have a SQL Server OLTP, right? We've got, our source data sitting in a SQL Server database.
Yes.
Our SQL Server server. And what's the process to get that into here?
All right. So the current process is to use Data Factory, which is just a kind of reskinned version of Azure Data Factory. And if it's our OLTP database, what we're probably doing is just bringing our tables in and creating staging tables in our bronze layer. And then from there, we will build out sort of our facts and dimensions. So that's pretty similar to what I do today in my on-premises BI work, right? I pull data from my different SQL Server and Oracle servers over to a staging area, and then I do the transform and land that in my facts and dimensions. So it's an ELT pattern rather than an ETL pattern. So we extract, load to staging or load to our bronze layer, and then transform into our silver and gold layers. Now, there is going to be something pretty exciting coming that I can't talk about that's going to make that even easier. There's something in private preview that I think you're going to enjoy. And that should hit public preview in a few months. But you're kind of exactly the scenario that you're talking about is the tool. They've got a tool that they're working on to make that super easy. But for now, you would do the classic, ELT pattern that I mentioned with the loading into the bronze layer and transforming from there. Does that answer the question?
Yeah, it does. And typically for you, are you typically using replication to do that, or are you doing something more like an insert, a destructive insert?
Yeah, usually it's a destructive insert. Now it doesn't necessarily need to be that. We've got access to, say in this case, we could use Spark and do some merge inserts into our, some merge upserts, sorry, into our Delta tables. Spark's probably the best tool for that. It kind of, it's like anything in our field, right? It depends. Like, how big are the dimension and fact equivalents that we're bringing over? But so, we do have a couple options. All right, so let's hop. Thanks. All right, and again, now we've seen the warehouse. We've got here's a learn more link. So this is the most common question that comes up, right? How do I know whether I'm going to do a lake house or a warehouse? So we've got kind of four main things to think about that'll swing you one way or the other, but you can have both. We'll talk about that too. If I'm looking at only structured data, that's probably a warehouse thing. Whereas if I've got JSON and XML, other types of unstructured data, I'm thinking more of a lakehouse structure. If my users are using Spark or they're data engineers and data scientists, that's a good lakehouse model. If they're SQL developers, data analysts, they're used to using T-SQL, the warehouse experience fits that better. And if we've got kind of like we're able to get a flattened out tabular data that's in a star schema that's real easy to query, again, that's a warehouse type of thing. But if we've got a really complex data structure, where we're needing to write complex PySpark or use some Python libraries to help us analyze it, that's more of a lakehouse structure. Now, I've linked a video here from Advancing Analytics from the UK. Simon Whiteley will go into 20 minutes on this piece. It all comes down to who are your users and what tools do they use. But we can have, just like in my demo now, I've got a lakehouse sitting there, I've got a warehouse. So if our sales team has a lot of data engineers, but our marketing team they've got a splinter group, they're all SQL developers, that's fine. They can build a warehouse, sales can build a lakehouse, and we can actually query them, both together, because, ultimately they're just parquet tables. So here's another slide from Christophe kind of going into the same thing we've just talked about. So the data science model, I don't have any demos prepared for it, but we're looking at doing the same things that you're doing today in the Azure machine learning experience. So you're using notebooks to train your models, you're building experiments to evaluate the models, And then when you've got like the winning model, you can store that in your workspace and refer to it in your other data artifacts. So you might have a scoring model that you use as part of your transformations. Yeah, store the model in the workspace and you can access it directly. So super cool stuff. Yeah, I don't have a demo prepared for the real-time analytics story, but that's when you're streaming large quantities of data, and it's almost always going to be time series analysis. So think of sensor data coming in with timestamps. And so even though we're storing that in a in a parquet table, still if we're using the real-time analytics, we have to use Custo to query it. So that may be a new experience for some of you, but KQL is pretty easy to learn. And in some ways, like if you're starting from scratch and you don't know any query languages at all, Custo is probably even easier to learn than SQL. But again, another link here for you to go learn more. And so Power BI, we've seen how easy it is to turn that data set into a report with just a couple clicks. But one thing we need to point out is, see this yellow band here? This is the pattern we're using. It's something called direct lake. So in the past, we might have had sort of the green has the lakehouse and warehouse, and we import that, we make a copy of it in our Power BI data set, and once we have that copy, the Power BI report is super fast, but we have to set up a refresh schedule, and it may take a while to refresh if we've got a ton of data. So we're not going to do that anymore. In fact, this is more like the direct query that we have, which is the purple on the top, where we've had that capability in Power BI to, rather than query the Vertipack data set, to go query a SQL Server or an Oracle Server or a Snowflake and bring that data back in real time. But it's not the fastest because we're sending a query directly to an unaggregated database. But what we've got here is the best of both worlds. We've got a direct query equivalent straight to the Parquet files in our data lake with an engine that's been optimized to read in huge amounts of data from those Parquet files and bring it in very, very quickly. So again, no more refreshing our Power BI data sets. We're just going straight to our Parquet files. So one copy of the data. Now, this does have, currently in the public preview, there's a few limitations here. I think I've got these. I think I have these pulled up. I think that, yeah, here we are. So we have some size limits. Here's the biggest piece right now. We're not yet supporting calculated columns or calculated tables. Still not 100% covered all the data types. And this is in, there's still some bugs to be worked out, right? We're still in our public preview, right? So I've said that a couple times. What I haven't mentioned, for those of you who might not know how this works, Microsoft does their internal development, and then they pick some customers and maybe a group of MVPs or other people they're well connected, and they'll go through a private preview. And there'll be feedback to the development team. They'll make some changes, and then it gets into public preview where all of us can, create a trial. In this case, what they call a capacity, and try it out. But in the meantime, there's lots of other components and different pieces being added. I think if you remember back to when Power BI first came out, we were getting new features like every single month. There was a completely new release, and we had to update all the time, but we were getting a lot of new functionality. Again, going through that development, private preview, public preview, general availability pipeline, but still coming very fast. So yeah, we're still in, as I said, week 7, week 8, maybe. So we've got a lot more to come. A lot of these known issues are going to be going away by the time we hit general availability. All right, so here's the slide that you were waiting for. Let's talk about licensing. So high level first, if you've already got Power BI Premium, you have Fabric today. You have a what they call a Fabric capacity built in. So great, you can start building these and playing with them. But if you don't, you're going to need to buy a capacity in SKUs that are the stock keeping units from F2, every power of 2, F4, F8, up to F2048. And those are the number of capacity units that you get. Right now, that capacity unit is 18 cents an hour per CU. So if if you're not ready, if you don't do the free trial that's in play right now, and you just want to start your own, F2, the lowest level, that's going to run you about $9 a day for a compute. We'll come back to that in a second. Remember, compute and storage are separated, so we are having to pay for our storage. So it's about 2 cents a gig a month or $23 a terabyte a month. Now, all of these prices can vary from region to region, so be sure to check them out before you commit. But going back to our capacity, each CU is, I think that's basically 2 cores, right? So an F2 is really like having 4 cores. But it's not like running, 4 cores and only 4 cores 24/7. They have something called smoothing, which allows you to go up to use more cores as the workload demands it. But then it averages out across the day. So if I've got, let's say an F8, where I've got a process that runs for an hour that takes up, an F32, that's fine, as long as I'm not hitting that F8 all the rest of the time through the day. It averages out, across the day, if that makes sense. So when you're looking at sizing, you're really looking at your average size throughout the day rather than your peak size that you might be looking at, in an on-premises situation. Still though, even if you've got that, if people do need to create Power BI items, they are going to need to have a pro or premium license on top of that. If they're just creating Fabric pieces, well, they can use the portal for free. I should say all the costs on the capacity as of today are pay as you go. They have announced plans for a reserved pricing structure. How that usually works is you commit to a year or 2 years or 3 years, and they give you a 30-40% price cut for committing to that length of time. Now that they haven't announced what the details are, just that is, they will announce that before GA. So keep an eye out for that. But for right now, we've got a free 60-day trial. And in fact, if we go ahead and look here, it says 59 days left. That says 59 days every day. So I think until we get to general availability, this 60-day trial is really just a permanent trial until general availability, at which time this 59 will start to drop down. You're not paying for, let's go back to the slide. I'm not paying for any of that capacity as long as it's a trial. If I'm building a lot of storage though, I'm still going to have to pay for that storage, on top of this. But so we've got 60 days to try it out. One thing I should mention, when I first set up my trial, I did things in the wrong order, and I accidentally set up an F2 for myself, and then I set up the trial, and they were separate capacities. So I started racking up $9 a day. But this isn't the first time I've made a little Azure mistake, right? A lot of us have probably done that. So I knew to go in and monitor the cost analysis report to make sure that I wasn't using more than I expected. So like, if you go and set up your trial, just go back into the Azure portal a little later and just check, every couple days that you're not actually racking up, your $9 a day or more if you choose a higher capacity. In theory, all of the trials are F64s, which are pretty beefy. So you should have, unless you're a really giant enterprise, you should be able to evaluate a good sized data load here. All right, so that's all the details. So I'll leave you with some resources and then I'll take some more questions. So this presentation is uploaded to my GitHub. Let me drop that in the chat. Let's see. Oh, you know what? I can't access the chat. So Steve, if you could, if you have access to the chat, could you type that in?
Sure.
But you can get that deck, and then all these other links are right in there already. So we've got a couple articles. These are the standard, here's the introduction overview type of thing. Good to send to your boss, who doesn't want to be too technical, to say, hey, this is coming. Lots of good tutorials already on the Fabric Learning site. We've got some great videos. That's the first link here. If you were disappointed that I didn't cover the data factory experience or the data science experience, they've got some webinars that show demos, and they cover about 15 to 20 minutes on each of the kind of 6 pillars that I showed in the original diagram. And then everybody loves Guy in a Cube. So here's a link that all the Fabric videos that Adam and Patrick have made so far. So these will be great for you to go back and watch. They're super funny guys. I'd highly recommend watching those. All right, so
it looks like there is a question from Tim as well, from Tim again.
Okay.
Yeah. So for those of us that have our data warehouses in a SQL Server today, is there, and we don't really have any data scientists. I mean, everything that we do is pSQL and stuff that can access SQL Server very well.
Yep.
Is there any compelling business reason for us to say, hey, let's move this from SQL Server to Fabric?
I don't think so necessarily. But I will tell you what I'm seeing at my client right now is they're about to go to basically upgrading their last business system. And at that point, after they've done that one, all of their business systems are going to be cloud-based. Right? I mean, third-party hosted. But at that point, really the only thing that they have on premises is going to be their data warehouse server. So at that point, you start wondering, does it make sense to continue to have like an on-premises, does it make sense to have like a data room, or have a colo facility at that point, because everything else is in the cloud. In fact, even pulling data from those systems, they're not going to give us a direct link. So we've got to create APIs to pull data down. Usually it's in JSON format. Sometimes it's just comma separated, but a lot of times it's JSON. Well, ultimately we're going to be throwing those into a data lake. But if you're in the situation you are now, where everything's on-prem, like, great,
Well, let's
stay
say it's in the
on-prem.
let's say it's in the cloud now. I mean, ours is on-prem, but our plan is to go in the cloud. But so let's say we're on Azure, right?
Yep.
There's still SQL Server. At least that's the way I look at it.
Yeah. So I think then the compelling piece becomes, well, I can point all of my data practitioners, like my pros and my citizen developers, at the same area, and they can all work together, right? I don't need to be like, I know something that's, pretty common where I am now is, somebody needs a report. It's a one-time thing, but it's got to cover data from a couple different sources. Our business users can't join data, right? But they can copy files into a lake, make that data set, and put the Power BI report on top of it. They can do that without having to wait for like a more structured IT experience. So yeah, that's the kind of thing that Microsoft is aiming for, is like an all-in-one, let's make this a software product rather than a platform. And then we don't have to figure out how to tie all these different platforms together. We just have one software project that both the pros and the, what they call, for the lack of a better term, the citizen developers can use. So if that kind of structure could benefit your organization, then that could be a compelling reason as well. I mean, there are other things, like if you have to wait hours to get, a Power BI data sets or analysis services data sets refreshed, and that's becoming a backlog. This way is going to, remove the need for, making that extra copy of the data. So, as always, it depends, but that's a couple of the business cases that are, I think, immediately compelling to me.
Thank you.
And also just, this is where they're, from some of the the meetings and conferences I've been in, this is where Microsoft is pouring all their attention, and all their different teams are working together, to make this one experience. So
There is another question from Bahram.
Hello, Chris.
Hello.
How are you?
Well, thank you. Maybe melting a little bit because it's pretty warm here in New Mexico.
I have one simple question. So basically, Microsoft didn't create anything new. This is only they unified some services together to create this one. Lakehouse is based on Databricks Lakehouse, right?
Well, so it's based on the Databricks paradigm, but they're not building any actual Databricks tooling in here, but they are. If I go back here, we do have Spark pools, but that's the same way that in Synapse today we have Spark pools that are not Databricks Spark pools.
So this is totally different than that, right? The different service, they created their own lakehouses.
Yeah.
Oh, okay. Thank you.
But to open standards and the same paradigms that Databricks uses.
Oh, okay. Thank you.
You're welcome.
See any
Steve,
more questions?
any more
I'll
questions?
go back to my slide deck. I don't see any questions. So I'll go back to my slide deck.
All right. Well, thank you everyone for having me. Uday, is that another question from you?
Yes, so I have a quick question. So what is the largest database size, right? This Fabric can support?
I'm not sure if they've announced that yet.
Mm-hmm.
So I would, yeah, I would be making up a number.
In terms
It's intended to be, multi-terabyte, probably bigger.
Okay, okay. And is this system suitable for OLTP workloads?
Not today.
Not today. Okay.
Yeah, this is an definitely an analytics product.
Okay, okay. Okay, yeah. Thank you, Chris. Yeah. The whole session very informative, very useful. Thank you so much.
Oh, thank you for the kind words. I appreciate that.
Chris, thank you for your awesome presentation. Let's wait for maybe a few more questions.
All right. Well, yeah, if y'all think of any questions later, I'm Chris Hyde 325, everywhere, but particularly Twitter and Gmail if you want to send a question later, or find me on LinkedIn if you'd like to connect there. Okay, well, thank you all again for having me. Yeah, really appreciate getting the chance to talk to you all this evening.
Despite the initial hiccup. I think I saw a question from someone.
No question.
Yeah, thanks, Tim.
Standing ovations, I guess. This session is recorded and will be published on YouTube and Rumble once it's published. Thank you everyone for joining our online meeting today. With that, thank you. Have a great day and see you in the next meeting. Thank you, Chris.
All right. Thanks, y'all. Take care.
Thank you. Bye-bye.
Bye-bye.